58 million. Just let that massive number sink in for a second. Because as of 2024, that is the staggering size of the global electric vehicle stock. We're really not talking about some tiny niche market anymore, right? We are looking at a fundamental, massive shift in how the entire world moves. So, welcome to this explainer. Today, we're going to completely untangle the supercharged, sometimes totally fragmented, but absolutely fascinating world of EV charging standards and futuristic next-gen technologies. Seriously, if you've ever wondered how all these different cars, plugs, and power grids actually talk to each other, or what on earth happens when the grid just isn't enough, you are definitely in the right place. Here's our quick roadmap for today's journey. First, the electric vehicle boom. Second, decoding charging modes. Third, the global plug puzzle. Fourth, next-gen charging tech. And finally, powering off-grid futures. All right, let's kick things off with Section 1, the electric vehicle boom. Scaling up the sustainable future. We're starting out at the macro level here because the undeniable, explosive growth we're seeing is totally reshaping global energy consumption. Look at this. With global EV sales surpassing 17.3 million units in 2024 alone, we're talking about a massive 25% year-on-year jump. That's huge. This isn't just a slow, gradual rollout anymore. This rapid rise instantly highlights a really urgent, pressing need for robust charging infrastructure. Because think about it, all those millions of new cars hitting the road, they need power, and they need it to be convenient.
Which brings us perfectly to Section 2, decoding charging modes, speed and power.
To keep all those millions of cars moving, we really have to talk about how we actually push power into the batteries. And I love this breakdown because you can clearly see the progression in capabilities. We start at the top with Mode 1. That's your slow, overnight sip of just 1 to 5 kilovolt amps from a standard household plug. Then you step up to Mode 2, giving you a semi-fast charge over a few hours using a dedicated AC supply. But then, look down at that bottom row. Mode 3 is just a massive leap. We're talking heavy-duty, ultra-fast DC charging that blasts anywhere from 50 to 400 kilowatts of power directly into your car in mere minutes. Now, the really crucial takeaway here is that as the charging gets faster, the physical infrastructure has to get significantly heavier and a lot smarter. If you look at how this is laid out, notice where the protection systems live. For Modes 1 and 2, the main safety checks and the AC to DC conversion happen right inside the car itself. But for Mode 3, to handle that absolute fire hose of direct current, all that heavy lifting and protection gets moved out of the vehicle entirely and into a massive, dedicated external DC charger. To put that top tier into perspective for you, taking just a quick 20-minute coffee break at one of these super fast chargers can literally juice up your car for a 120 to 180-mile road trip. We are rapidly moving away from that old concept of charging overnight and getting incredibly close to the traditional gas station refilling experience. Let's move on to Section 3, the global plug puzzle, connecting different standards. So, getting that incredible amount of power into a car safely requires a very specific and honestly highly regional handshake. As you can tell, the world is currently navigating a pretty fragmented plug puzzle. North America largely relies on the J1772 and CCS standards. Europe, on the flip side, mandated a harmonization around the Type 2 protocol, which makes sense because it's perfectly tailored for their three-phase power grids. Meanwhile, over in China, they operate on a strict, incredibly robust national standard called GB/T. And Japan? Well, they were actually the original pioneers of DC fast charging with their CHAdeMO standard. It's totally a global patchwork, which is exactly why interoperability is such a massive hot topic for manufacturers today. But it's really not just about the shape of these plugs, it's about sheer physical endurance. These connectors are built unbelievably tough. Take the North American J1772, for example. It is engineered to survive 10,000 mating cycles. Just to put that into human terms, it would literally take you over 27 years of daily plugging and unplugging to wear that single connector out. That's wild. And beyond that tough physical exterior, right behind the scenes of that plug is a really smart little digital handshake. When you plug your car in, basic signaling first verifies the physical connection and ensures everything is completely safe using a simple pulse signal. But for the really cool stuff, high-level communication kicks in. This lets the car and the charger actually talk data to each other. This is exactly what enables the ISO 15118 standard, which you probably know better as plug and charge. It means the charger securely authenticates your car and handles the payment automatically. No swiping a credit card, no messing with an app on your phone. You just plug in and walk away.
All right, Section 4, Next-Gen Charging Tech, Cutting the Cords and Bidirectional Power.
Okay, imagine if your car was actually a mobile battery that literally paid you back. Well, that is the magic of vehicle-to-grid or V2G. Instead of just pulling power one way, this bidirectional tech lets your EV discharge its surplus energy back into the electrical grid during peak demand times. This helps utilities balance the grid, it reduces our reliance on dirty fossil fuel peaking plants, and get this, it actually allows you to sell your stored energy when electricity prices are at their highest. Your car literally becomes an active, money-making participant in the energy market. Or, taking it a step further, imagine tossing the physical cable altogether. Enter inductive power transfer. This is where resonant magnetic fields beam energy across a physical air gap directly from a pad on the ground straight into a receiver on your car. Not only does this make home and public charging completely frictionless, but it's genuinely paving the way for dynamic highway charging. Imagine just driving down a specialized lane on the interstate and literally fueling up your battery while you're cruising at 65 miles per hour. Let's wrap up with Section 5, Powering Off-Grid Futures. Energy where the grid can't reach.
So what happens when we want to charge these vehicles in places where the traditional grid simply cannot reach, or just doesn't have the capacity? Well, the answer lies in some truly innovative off-grid miracles. We're talking about solar-powered stations that use local battery storage to hold power for cloudy days. We're seeing wind energy microturbines combined into hybrid systems with biogas or fuel cells for unmatched reliability. And for commercial fleets that absolutely cannot afford any downtime, we are seeing automated battery swapping, literally dropping out a depleted battery and bolting in a 100% full one in about 3 minutes. That's basically the time it takes you to run in and grab a snack at a rest stop. And the sheer financial power of using local storage like this is fascinating. Usually, installing ultra-fast chargers requires massive utility substation upgrades, which can take years and cost millions of dollars. But by using a battery buffer right at the charging site, the station can just slowly sit power from the existing grid, store it all up, and then blast it into a car when it pulls up. This clever strategy can reduce capital costs by 65% and shave up to 5 whole years off project timelines. It is an absolute game changer. And battery buffers aren't even the only way to store that energy. Consider this absolute mechanical marvel. By hooking up solar and wind generation to a spinning mechanical flywheel suspended in a vacuum, these stations can literally store kinetic energy. So when a massive vehicle like an electric city bus pulls up and needs an immediate massive pulsed power spike, that flywheel rapidly decelerates, converting all that kinetic energy back into electricity instantly. Or we can look at this incredibly cool compressed air energy storage system. In this setup, excess green energy from solar or wind is used to compress air into massive storage tanks. Then, when grid demand peaks or a car needs ultra-fast charging, that highly pressurized air is released through an air motor and generator, providing this massive burst of clean electricity to power up your car right on demand. It's just brilliant engineering. We have definitely covered a lot of ground today. We've moved from the raw, staggering scale of the EV boom down to the messy, fragmented puzzle of physical plugs, and all the way out to wireless, off-grid, and bidirectional networks that are completely rethinking the very nature of energy. Which leaves us with one massive, thought-provoking question for the road ahead. As these technologies mature, will your next car be just a vehicle that takes you from point A to point B, or will it be a mobile power plant actively shaping our sustainable grid? Thanks so much for joining me on this explainer, and remember to keep asking the big questions.